So the first question I see, is SureMix commercially available? Do we have a global distribution network? It's a very good question. Yes, SureMix is commercially available. We have a brand new state-of-the-art facility that went operational in 2018. It's been audited to VDA 6.3 standards by one of the tire companies. We're currently actively selling in multiple regions of the world in container load quantities. Our main markets right now are Europe, South America, and North America, with, I would say, soon to expand into applications in Asia. We do have distributors who handle some of the Asian countries. So if you're interested in samples or in commercial quantities, let us know and we'll put you in touch with the distributor. Thank you, Para. The next question is, are both grades of SureMix REACH registered? That's correct. Yes, they are REACH registered. We have active sales into Europe right now. We are also registered with TASCA for North America, K-REACH in Korea, and as I said, we're expanding to Asia, so we're working with the Japanese regulators to have SureMix registered in Japan as well. Thank you. The next question is, I've tried different process aids in silica, most reduce modulus and many slow the cure rates. How about SureMix? That's a very, very good question. Yes, most of the process aids do reduce the modulus, and that's one of the biggest challenges we had in the introduction. So customers who are accustomed to using no process aid or 1 or 2 PHR were very concerned about increasing to 5 and 6, and maybe even as high as 8 PHR of S6 and highly loaded compounds. So our products, if used as recommended and mixed as recommended, do not negatively impact the modulus. If you put 15 parts, I'm sure it will, but in the 4 to 6 PHR range, we've been able to maintain modulus. One of the grades we mentioned is CO squared. The reason we called it CO squared, the first one was cure optimization. The second CO was hysteresis or carbon dioxide reduction. So rather than call it CO2, which wouldn't be acceptable, we called it CO squared. The cure optimization was designed into the product to give us a long scorch time with low Mooney viscosity and then a rapid sulfonamide type step cure. So if you have silica compounds, CO squared is the preferred product and it won't negatively impact modulus or reduce the cure rates. Thank you, Para. The loading for SureMix is higher than conventional process aids. Does this lead to problems during mixing or negatively affect properties? I would say this is a follow-up of the previous question. If you stay within the recommended loading, and we recommend loadings based on the filler content, not the polymer content. So, for example, the upper limit recommended for SureMix CO squared in silica compounds is 6 PHF. So if you have 50 PHR of silica, we would recommend 3 PHR of SureMix. If you have 100 of silica, we would recommend 6. Of course, the surface area of the silica makes a difference. This is all based on 160 meters squared. So higher surface area, we could give you recommendations. So if you stay within these parameters, there's no negative impact on mixing or properties. In the case of S6, which is used predominantly in carbon black, again, we have similar guidelines, and we also have mixing guidelines where the sequence of addition of the products is very important. For example, with S6, antioxidants, zinc oxide, etc., we request that those are moved to a later pass. So SureMix would be added up front, and some of the other compounding ingredients that can interact with SureMix are added later on in the mixing cycle. So if used at the right loading, mixed properly, there's no negative impact on properties. Thank you. This is an excellent question where a little bit of silica is added to a carbon black compound or vice versa. So I would say it depends on so many compounds have a blend of silica, carbon black. Can it be used in those compounds? If yes, which grade of SureMix should we select? So our recommendation, if you have silica in the compound, add SureMix as a ratio of 6 BHF of the filler, 6 parts per 100 of the filler. And if you don't achieve your, sorry, this would be CO squared. If you can't achieve your processing requirements, then you can add S6. Both the grades can be used synergistically, where CO squared has more of an impact on the properties, and S6 is designed to have more of an impact on processing. So blending these together can again give you a balance of properties as well as processing. Thank you. The next question is, can you comment on SureMix inclusion and benefit on non-tire applications? When we introduced the product, like many suppliers to the raw material industry, when you're building a plant, you want to focus on base loading the plant, which we've done with our customers. Since then, we have increased our focus in non-tire applications. And there's a wide variety of applications. For example, automotive hose and weather strip, EPDM-based compounds. These compounds are non-staining, but they have very, very improved, and they have very improved processability. If in cases where you've got a very hard hose compound, which is difficult to extrude, for example, a sandblasting hose. You want a hard material, but you can't use a processor. SureMix works in those applications. We've got some niche applications from footwear, uh, recreational boats. A growing area is conveyor belts and mining belts, where again processing is important without compromising the performance of the product. So we've seen a wide variety of applications expand for SureMix, as well as the polymers. So the main non-tire polymers are NPR, HNBR, EPDM. One area that we've stayed away from is chlorinated polymers, such as halobutyl or CPE. These SureMix can interact with the cure of those compounds. So if you have a non-halogenated application, halogenated polymer use in your application, I would say try it in your lab to make sure there's no cure interaction. But besides that, there's really no limit on the use of SureMix. It's a pale yellow to white product, so it doesn't add any color. Some of our other process aids are darker in color. So SureMix can be used in a wide variety. Anywhere where you have processing challenges and you can't use conventional process aids or oil, SureMix would be a good option. Thank you. What is the sanctity of testing dynamic properties of uncured compound through RPA? Well, we we prefer dynamic testing of the uncured compound versus on an RPA versus a Moody because it gives us, I would say, more relevant information, and we found better alignment of properties or extrudability and performance versus a lab test. We widely use the G prime to measure processability and tan delta of the uncured compound to look at the quality of extrusion. Higher the tan delta, smoother the surface, lower the G prime, the better the extrudability of the compound. We use the RPA because the instrument that we have is the RPA, but there are many other dynamic testers, some even more capable than the RPA, that would give you that type of information. Other approaches like the Garvey dye or capillary rheometers are either more time consuming or they use a lot of material. So when you're in the lab and you just want to use 5 or 10 grams of material to analyze your product, the RPA is an extremely useful instrument. Thank you. The next question is what types of silanes is SureMix compatible with? I haven't found a silane so far that SureMix is not compatible with. So we've done a lot of lab work and high performance silanization with both disulfide and tetrasulfide, the Si69, the Si363 type. Excuse me. And we've also published papers with the new generation of momentive silanes like NXT, Z45, etc. So we found good compatibility. The performance characteristics are a little different, but what we have seen in general is a improvement in processability irrespective of the silane used, and in some cases improvement in properties with the use of SureMix. So it's pretty wide compatibility. SureMix is designed to improve the hydrophobation, and that that's what allows one to reduce the silane loading. It also helps prevent the silane to silane condensation. So quite widely compatible. Thank you. And if there's any information you want or further studies on silane compatibility, please get in touch with us. We can share the information with you. Thank you. Is SureMix compatible with NBR and EPDM as these are widely used in the rubber industry? Yes, it is. As I mentioned earlier, we have a number of automotive and non-automotive EPDM applications, and we're seeing a growing number of NBR applications in the rubber industry. What it the benefits are, I would say, similar. In the case of NBR, we were quite surprised at the significant improvement in processability. This was a compound which was quite a challenge to mix, and it wasn't even, I would say, a full carbon black compound. It had clay and other materials. Uh, it was a one pass with 30 minutes, 20 to 30 minutes on the mill. With SureMix, I would say with our process aid and mixing strategy, we were able to keep the mill time down to about 2 minutes. So the customer went from a 30-minute per batch down to about 8 minutes a batch, a dramatic decrease. Furthermore, because this was a hard compound, extrusion was a challenge, and they had high scrap rates, all that was eliminated with the use of SureMix. Thank you. Can SureMix be added during mill mixing? That's a good question. I know in Asia, especially India, there are a large number of mill mixers. Uh, our preference for using SureMix is an internal mixer like a tilt mixer or a Banbury. It can be added on the mill. You have to be careful with the temperatures. Uh, CO squared softens at about 85 degrees, 85 degrees, and S6 at about 115 degrees. So you need enough residence time to melt the product, have it homogeneously dispersed, and interact with the polymer filler system. We've seen cases where mixing with S6 was done at about 90 degrees to 100 degrees, and they were not able to obtain the properties they were looking for, the processability. Just by raising the temperature to about 140 in that study, there was a dramatic decrease in the viscosity and improvement in the properties. So, mill mixing, yes, it's possible. Just make sure you reach the temperature to melt and disperse your mix. Thank you. The next question is, what are the main applications where SureMix is being used in tires? So let me tell you a little bit about the history of SureMix. SureMix was initially developed to help customers increase the silica loading without processability drawbacks. So the tread was initially targeted. Since then, I would say right now, uh, especially with the case of S6, the largest applications are truck tires and retread carbon black compounds, where the viscosity reduction without losing properties is quite dramatic. So the tread is a predominant application. We now know, of course, tire companies are quite secretive on what they're doing, but we have indication that they're looking at non-tread uh, sections of the tire, like the undertread. The reason for that is it reduces hysteresis if you and improves processing, of course. If you want to reduce the total rolling resistance of the tire, the tread is a major component, but other components like the undertread or the sidewalls also have contributing benefits. We also know it's being tested in very hard, like apex compounds, which are difficult to extrude. SureMix is being looked into those applications. The only one we caution people not to look very carefully if you want to move in that direction is make sure you do your cure analysis and cure studies is the inner liner. Halobutyl's cure rates can be affected quite dramatically with SureMix. So I would say stay away from that. Otherwise, there isn't a tire component, a major tire component that could benefit from SureMix. Thank you. The next question is, what are the main engineered rubber applications for SureMix? So if I look at currently, I would say the biggest non-tire applications are conveyor belts and hoses. I think we've got a major program which will start commercial production next year. It's in EPDM weather strip. So those three weather strip hoses, especially hard to extrude hoses and conveyor belts, mining belts, these are the largest non-tire applications. Thank you. The next question is, can the different SureMix grades be used together in a formulation? And are there any benefits to doing so? So the first part, yes, it is used as a blend in many formulations, and there are benefits to doing so. So especially in the case of blended compounds where you have part silica, part carbon black. In those cases, say if you have a 30-part silica compound, the recommended SureMix CO squared loading would be 1.8 pHr, which is 6 phf. In those cases, the drop in viscosity with 1 or 2 parts of SureMix is not significant. You could add S6, 3 or 4 parts of that, and get the viscosity drop you need without compromising property. So if we are trying to optimize performance versus processability, at times it's beneficial to use a blend of grades. And they are being used as blends today to meet the processing requirements. Thank you.
Thank you very much, Dr. Ricky. That's all the questions we have for this discussion.